Tomorrow, we're going to take what we learned today and we're going to apply it to solving rational equations. So, here we have a rational equation. 2 equals 4 divided by n plus 1/3. And, just like before, we need to find our least common multiple. In this case, our least common multiple is 6n. So I need to end up with 6n in the denominator of all three of my fractions. So to get, since there's nothing in the denominator here, I've got to multiply 2 times 6n over 6n. I've got to multiply 6n on the top and the bottom. It's as if there was a 1 on the bottom here. Equals, and this has already got an n, so I've got to multiply 6 times the top and the bottom. And this has already got a 3, so I need to multiply 2n times the top and the bottom. And when I simplify the numerators, and that's the important part, we're going to get 12n equals 24 plus 2n. And at that point, really, that's all we need to solve, is the numerator. I'm going to show you a little trick in a second here where we can actually shortcut that step, but end up with 12n equals 24 plus 2n. Subtract 2n from both sides to get 10n equals 24. Divide both sides by 10 to get 24 over 10, which when reduced is 12 over 5. So, here's the shortcut. Instead of trying to get denominators that equal 6n, just take the 6n and multiply it by the whole fraction. Excuse me, by the whole equation. So 6n times 2 is 12n. 6n times 4 divided by n is 24. And 6n times 1 divided by 3 is 2n. Same equation we had before, going to give us the same solution. So let's try it when we got some extra x's floating around instead of just 1 sitting right there. Theoretically, I could have gotten this fraction by itself and then cross-multiplied, but this is easier as you'll see. And of course, it doesn't work in this case. So here we got denominators 3, 4, and 2. And the least common multiple will be 12. So we're going to multiply 12 times the entire equation. Well, 12 over 3 reduces to be 4, so I multiply 4 times 2x plus 1. 12 over 4 is 3, so I multiply 3 times x minus 5. And 12 over 2 is 6. And now it's just solving equations. Distribute to get 8x plus 4 minus 3x plus 15 equals 6. Gather my like terms to get 5x plus 19 equals 6. Subtract 19 to get 5x equals negative 13. Divide both sides to get negative 13 fifths. And of course, got to remember those excluded values, and you'll have at least one on your practice work this will come into play here. In this case, don't want to divide by 0, so n cannot equal 0. And 2 more examples for you. 2 equals 5 over 2q plus 2q over q plus 1. The least common multiple is 2q times q plus 1. So take the whole equation and multiply it by 2q times q plus 1. Well, there's nothing in the denominator here, so I've got to multiply 2 times 2q times q plus 1. That's 4q times q plus 1. The 2 times the 2 is where I got the 4q from. 2q times q plus 1 divided by 2q. The 2q's will cancel and leave me with 5 times q plus 1. And 2q times q plus 1 divided by q plus 1 leaves me with 2q. And so 2q times 2q is 4q squared. And now it's just solving. Distribute gives me 4q squared plus 4q equals 5q plus 5 plus 4q squared. Subtract 4q squared from both sides to get 4q equals 5q plus 5. Let's see, Mr. Benfield just walked in. Let me see if I can pick up where I left off here. I got 4q equals 5q plus 5. Subtract 5q from both sides, divide both sides by -1, and I get q equals -5. One more example, and this is probably about as tough as it gets. 2f over f squared minus 4 plus 1 over f minus 2 equals 2 over f plus 2. Least common multiple, f plus 2 times f minus 2. That's what this factors to be. So, f plus 2 times f minus 2 cancels with this f squared minus 4, so I'm left with 2f. This f minus 2 cancels with this f minus 2, so I multiply 1 times f plus 2 to get f plus 2. These f plus 2's cancel, so I'm left with 2 times f minus 2. Distribute to get 3f plus 2 equals 2f minus 4. Subtract 2f from both sides, subtract 2 from both sides, and I get f equals -6. Make sure you post any questions you have in Edmodo. And don't forget about those excluded values. Here, q cannot equal 0 and -1. Here, q cannot equal -2 and 2. And as you could probably imagine, solving inequalities is very much like solving an equation, except, of course, if we end up dividing by a negative number, which we will in this case. I've done one for you. 1 over 2m minus 3 over m less than -5 halves. Least common multiple is 2m, and our excluded value of m cannot equal 0, and that's going to come into play. So we're going to take our 2m, multiply that by our entire equation. These 2m's cancel, leaves us with 1. These m's cancel, leaves us with 2. 2 times 3. Then we have these 2's cancel, leaves us with -5 times m. 2 times 3, -3 times 2 is -6, plus 1 is -5. So we have -5 less than -5m. Divide both sides by -5. Here we go, dividing by -5. So I flip that sign over. What used to be a less than sign is now a greater than sign. So 1 is greater than m. Another way of writing that is m less than 1. Think about it. If 1 is greater than all the m values, then the m values all have to be less than 1. But m cannot equal 0. And 0 is one of those numbers less than 1, so we have to exclude m from being an answer.